Alright, welcome back to this series where we're going over Unreal Engine's character movement component in depth. So in this video we're going to be doing the climb mechanic, and so I'm splitting that up into, I actually did two separate climbs. So there's going to be this point-like climbing where you can jump from point to point, and then there's going to be sort of a free climb where you can climb the wall like sort of Zelda style. And I'll talk about like the reasons for that. And obviously the animations are not good. Don't look at those. That has nothing to do with the actual movement itself. And I didn't really spend much time on them because that's kind of for you guys to do. But it's all about the movement. And so if you're new to this series, we're going over specifically the character movement component, and that's because this series really targets networked or multiplayer movement. So if your game isn't multiplayer, you might not need this. I would always still recommend using the character movement component because it just gives you such a good framework for how your movement should look, and it allows you to maintain lots of different movement features, and it scales really well with complexity. But if you're not networking, then you can get away without it. But if you are trying to do a multiplayer game, you definitely need the character movement component. So if you're new, I would recommend to go back and watch the first two or three videos in this series because it really just goes over like all the kind of base information you need. And unfortunately, the character movement component is very complex. So we are going to need to be strictly in C++ for this, and there's just a lot that goes into it. So I would recommend going back and watching those if you're new to the series. Yeah, so the other thing I want to mention before we get into it is that I'm going to be doing the style a little bit differently in this video. So normally I paste in like the code snippets as I go time by time. But and that's just because I don't like to code live because there's just so much we have to cover, and the explanation is the valuable part. Like we're this is definitely like a intermediate to advanced type of tutorial, and so I trust like you guys are going to be you guys are going to know how to code and everything. It's mostly just that I'm explaining my implementation to you guys. So I'm not even going to be pasting in snippets this time. I'm just going to be basically because pasting in snippets is basically just already having the code there. So I'm just going to be going over all the new parts I added and explaining them. And then the other thing I want to say is that I highly recommend also if you haven't been doing this before, to follow along with the GitHub as you watch these videos. So I have pulled up here. I wanted to show you guys. I don't know if how familiar people are with GitHub, but so this GitHub is linked in the description of the video. And so what you can do is you can obviously right now you can just browse the files of the code, and this will be updated once I publish the branch. This will be updated to the latest version. But so you can go in here to the code, and you can go to the C++ file, and you can just see all the code here. You can download this and put it into your own text editor. But what's more helpful is if you go just back to the main branch, you can go to these, if you click on these 26 commits here, you can browse through and choose which kind of version you want to go back to. So for example, say you want to, you're following along with the mantle video, you can go to this mantle finished commit, and then this will have the code at that stage. And so first, when you click on this, you'll see a diff. So what's good about this is you can just go to, say, the C++ file, and you can see only the lines that I added or deleted. So like here, red is deleted, obviously, and green is added. So this will allow you to see exactly what I changed in the video if you're having troubles following along with the video. Or if obviously this isn't super useful. So then the other thing you can do is if you just go to browse files, then you can see like a copy of all the files at that point. So this is before I implemented anything else. And you can download this, obviously, just you can view it in your text editor just by just downloading the zip file. So I would really recommend using the GitHub in limbo with just watching this video, because again, like I said, the point of this video is to give you the explanation of the implementation. You can just look at this and copy this if you really just want the implementation. So okay, so finally now let's explain kind of what we're doing here. So okay, my motivation, so I like I said, I did two different climbing systems, and my motivation for that was because okay, climbing is just, there's so many different ways you can implement climbing. I mean, as for this is for all movement. Like there's just a lot of different ways that you can do movement, and everyone's game is going to have sort of different requirements. So like you guys, even I mean people in the Discord even made sprinting complicated. So I figured I didn't want to you know, marginalize a ton of different types of climbing systems by making like a very specific system. And I was split between, there's kind of this free climb like Zelda, and there's this point like climb, which is kind of like what you see in Assassin's Creed or other games like that. And I was originally just gonna pick one, but I ended up just picking both because they're really different. But I didn't make either one of them like super advanced because I'm gonna just explain in general how you could modify either of these systems to achieve different effects, because there's just a million ways that you could make a climbing system. And so I didn't want to I didn't want to go in depth on any one way. I just kind of made a general version that you guys can branch off of and add your own custom logic into. So yeah, so I'll start and explain the point-like system. So just a overview of the implementation. Basically, there's going to be these actors that are just any actor you want to create, and you put them into your level. And if you just add a tag to them, and in this case, I think I just call it like the hang tag. And then basically, we're going to override the jump input again, so that when you jump and you press space, you will do a cast, and you'll search for all the actors that have this tag of this object here, which has like that hang tag. And then if that's the case, you can just get the actor's location, and then you enter a new custom movement mode called hang, where you basically play this idle animation, and you basically have no movement control. So like WASDA does nothing here. And then I also had another jump override, but this time I'm overriding the jump execution. So before I was overriding the jump input. So I was not doing a jump, I was doing a hang, which is basically what you see here. And then after that, I'm overriding the jump execution to allow the player to jump off that wall, and kind of you can see they do a little bit of a push off. I don't know, it's kind of hard to notice because the animation blending, but yeah. So basically, there's this kind of enter and exit, and then the actual hanging state is pretty much nothing, and so you kind of just go between these different points. And also, I want to mention this is also kind of part of the high level implementation, is that the way, if you'll notice, when I enter the hang, you can see my character kind of snaps to that point, and you might notice that looks kind of similar to the way that the character snaps to, actually that wall's too high, the way that the character snaps to the mantle point. And that's because I'm reusing that logic, because that logic of kind of moving the character to a point, and I mean, I just usually call this a transition. That is like really reusable. You're gonna end up probably reusing this a lot, because it's just really helpful to, especially if you have any sort of like context or position sensitive mechanic where you have to be, for example, in this case, hanging to this specific point. Then using transitions like this are really helpful. So I'm going to show you guys also how I generalized the transition logic. And then, okay, so then for the Zelda climb, basically very similar, or sorry, not very similar, but similar to the wall run sort of. So basically you press, in my case, I just made it the G key, and then once you are like facing a wall and everything, you attach to this wall, and then you can use WASDA to like move around the wall, and it's velocity based. So like if I jump off here and then I press G, you can see like it tries to slow down my velocity, which is definitely a cool feature. The like keeping it sort of physics based. Obviously, you don't have to do that. You could remove like the velocity components, but I think that's cool just because it provides a little bit of inertia to the character. And there's no like, obviously, like this mechanic alone probably isn't that good for a real game, because there's no sort of limits to this system. Like you can just climb infinitely high. There's no stamina. There's nothing like that. Because like I said, like I didn't want to make a stamina system if like your game isn't going to have like that. Like maybe you just have a 2-second climb, or maybe you can only climb in certain zones. There's a million ways you can limit this climbing, so I didn't want to like pick one in particular. I think honestly, probably the two most common are going to be zones. Like you could make volumes, and then you could like only allow the player to trigger the climb in that volume, or you could make basically like a timer, like a 2-second timer before they run out of the climb, and then they just exit the climb movement mode. Or you could make a stamina, which like you utilize as you move, and if you stop moving, you don't use as much stamina, something like that. As you can see, the climb also has the jump. So I also override the jump logic to give you a jump out of the climb. And this is good because, you can do stuff like jump backward off this, jump backward off the wall, or you can keep jumping higher. I mean, obviously this is kind of busted because you can just kind of climb all the way up the wall. But obviously you can add your own sort of limitations to that depending on how your system works. So yeah, that's kind of the overview of what we're implementing. So yeah, let's jump into the code now. All right, so here we are in the code. And so like I said, I'm not going to be pasting in text live. I'm just going to be explaining it because it's kind of basically the same thing. It's just less cuts for me to edit out. And also, as I said, this is kind of an advanced tutorial, so I expect that you know at least how to code, and you're kind of more here for the explanation of my logic and following along with the GitHub. So yeah, I'm going to explain the hanging system first, which is that the Assassin's Creed type where you grab onto certain points in the map, and then I'm going to go over the Zelda climb after. But they're both kind of they're a little bit intermingled because this is kind of like a holistic climbing system. So there will be kind of shared logic a little bit between them, just as a disclaimer. So all right, let's start with hanging. So obviously there's a hanging movement mode. It's pretty self-explanatory. The player's in this state once they're grabbing the hanging object, and that's just the hang movement mode. There will be no saved move state data for either of these, which was actually kind of a hard feat to pull off. Normally you want to try to limit this as much as possible because the more state you have here, this just means that there's more room for kind of error or desync because other than the saved flags, all this state is not replicated. So the more you have variables here, basically the more options for desync to occur. Not necessarily, for example, this value is just kind of a derived value from other synced variables. So this will not probably ever cause a desync, but just in general, if you have a ton of more data in here, that can just cause more desyncs if you are not careful, basically. So yeah, I just managed to get all this to work without any of these state data. It was kind of all derived off of other variables, so that was just nice. And then so if we come down to the parameters for hang, there's these 3 parameters, and so transition hang montage is going to be utilizing our transition system. So if you've watched the mantle video, that's where I did transitions, and if you haven't watched that video, I would recommend it just because you will see, at least just watch the section, which I should have marked in the chapters where I make transitions, because again, like I said, the whole point of these tutorials is giving you different kind of key elements, different tools, and so one of these tools is the transition system, which I covered in the mantle video, which was definitely a long, and it was worth a whole video on its own, so I can't redo all that right here. But basically we use root motion sources to move the character. The whole point of a transition is just to move the capsule to a location where the movement can then start, because oftentimes for a climb or a mantle or something, the capsule needs to be in a very specific location to start that motion, such as obviously in this case the capsule needs to be right under that hanging point. So we're going to use this transition system to get them from any random location to that correct location. So basically we need this transition montage that will basically guide us into that position. And then we also have another montage, which is this wall jump montage. And this will be for just when the character pushes off the wall, kind of when they basically jump out of the wall, or jump off the wall, sorry. And then the jump force is the actual logic of what's going into changing their velocity after they press spacebar when they're in a hang or when they're in a climb. It's kind of, like I said, using the same system. So that's it for the hang, for the parameters. And also for the transitions, like I said, I did extend the transition system a little bit to make it more general so that we can use it in many different applications. So one of these things I did was I made this this is actually the only way I extend it, basically, is I just made this transition name variable. And this will just allow me to set the name of the transition, which then I can later, when the transition's finished, I can check that name and just do some if statements to check what type of transition we were just in. And then I can set the exit state of the character. So basically, you'll see in a second, but when we come out of or when we finish the transition into the hang, then we'll check that name, and if the name is a hang transition, then we'll enter into the hang movement mode. But for mantling, we'll check, oh, the name was like a mantle transition, and we'll enter into walking, because that's what you do, or sorry, we'll enter into flying, because that's what the movement mode you need to get into the root motion for the mantle. So it just allows me to get some custom logic on the exit of the transition, basically. So that's all I did to modify the transition system. And then as for functions, for the hang, it's very simple. There's literally just one try function, because there's actually, even though the hang is its own movement mode, we'll see that there actually isn't really anything going on when you're hanging, because the input, you can't do any input, because you're just hanging, and the only thing you can really do to get out of a hang is either press G to just fall back down, or press space to jump off that wall. So either of those aren't handled in the physics function, so it's just this try hang. So let's get into that, I guess, because that's pretty much the main implementation of the hanging system. So the first thing we do is we check if we're not falling and get out of that, because you can only enter a hang if you're in the air, basically when you're jumping or falling, whatever. That's in the character movement component, jumping is falling in terms of actual movement modes. So basically, if you're not falling, then we don't care. We can't try to hang. This is just a log statement I had for debugging. Actually, I could probably remove that now. So then we're going to get a wall hit. So we're going to get a cast from the character to like just in front of them to check if there's a wall there, because obviously you need a wall to hang on. So here we're passing in the component's location, and then the component's location plus the forward vector times 300. Yeah, I forgot, you can parameterize this value. I just picked 300. I wanted just a big number just to get the wall, because this isn't kind of the limiting value. So this can be really high, because we're going to do another cast that will restrict what we can climb on way more. So that's why I didn't really parameterize this. Block all, and then if you haven't watched my previous videos, you might have remembered from other videos that I use this get ignore character params, which just allows me to build a query param struct, which you always need to pass into line traces. Just allows me to build it faster. And all it does is just it ignores the I'll hop into it real quick. It just ignores the actors of the character, so that you don't line trace any of the character items, which is obviously pretty important for this movement stuff, because you can't move on yourself. Okay, so now we're going to do an overlap collision test, and this will allow us to search for actors that have that hang tag. So like I briefly mentioned before, basically we're going to try to find any actor in the scene that has a tag, the hanging tag, and then that can be what we grab onto. So I'm using the tag system to get hanging points, basically. And you can, again, like you can change that. You could make it so you only search for certain actors or certain classes, but I think the tag system is pretty good for this kind of a problem. So we're going to set our collision location, and that's going to be equal to the component's location plus the up vector times the capsule half height. So this section gets us to the character's head, and then we're going to go forward by a factor of 3 capsule radiuses. So this gets us 1 capsule radius just to get out of the character, and then 2 more to get in front of them. So this is where we're defining the kind of position of where we're going to create this overlap result. And then we are making a collision box, and this is of type F collision shape. It's kind of a weird type, but this is how you have to do overlaps. And we're just using the static creator for make box. And again, yeah, I didn't parameterize this one either. You can parameterize these values to edit them in the editor, but this is just kind of a collision box that I'm making, and I'm going to search for things in this box. And then we're going to make the collision rotation. So here's where we are utilizing that wall hit. So we are making a rotation, and I use this a lot, because this if you haven't seen this is super useful. It just allows you to make rotations from unit vectors, kind of like their orientation vectors. So the x vector is going to be the wall hit normal, so that makes it so that this box is going to be parallel with that wall, and then the up vector is just the up vector, the world up vector, because we're always dealing with kind of a Z is up system. We don't have any crazy rotations like I have to deal with always in my game. Um, and then we are doing that overlap, and then that overlap, so that overlap returns an array of overlap results, but it also just returns, well, it populates a array that was passed by reference, but it also just is going to return a boolean false. So if that's, if it didn't hit anything, then we're going to return false. And I'm using world static because I did by channel. I don't, you know, I use by channel and by profile a little bit interchangeably. I should really kind of get down what's the right one for that. I'm not 100% expert on this, like online traces like this, but I mean, if it's detecting the thing you want, then that's fine, but you probably should figure out like what objects in your game you're putting in different collision channels, because obviously that can affect things, like your movement. But yeah, here I for some reason did by channel, and I'm just using the world static. We're passing in that collision box we made and the parameters again, so we ignore the character. And if that didn't catch anything, we return false. And then we're making a null reference to this climb point, and then we're going to search for it in here. So we are going to search for climb points based on max height. So we're going to go through, we're going to iterate over every single result in this overlap result. And then we're going to check if the actor basically has tag climb point. So that's that tag I set. And then we're going to get the height of that actor, which is just the Z coordinate. And we're going to check if height is greater than max height. So we're filtering because here we're assuming we could have multiple climb points in our detection box, but we want to get the highest one because generally that kind of looks the best, because you always want to be moving the character up. Usually, I mean, you could make a system where you can climb down from these points. Obviously, you can fall down from these points, but yeah, basically I'm always getting the highest one, and that's the way I chose to do it. But you could also filter by like closest distance. This is just basically a simple min function or whatever, or max function. So we're just getting the max point that has the climb point tag, and we're setting that equal to that climb actor. And then of course, we could have only had 1 or 0 or no climb points in this whole search. So we have to make sure that that climb point is valid, because otherwise, if we never even got to this line right here, this would still be a null pointer. So if we never even found a climb point, then return false. But then obviously going on, we're assuming that we have a valid climb point because we are still in the function. So target location is going to be equal to, so this is basically how we're picking where the capsule should be from the climb points location. So we're going to get the climb points location, and then we're going to add the wall normal times the capsule radius times 1.01. So this is getting us back away from, because the climb point is directly on the wall, so this is going to get us backward and away from the wall. And then we're also going to go down by a capsule half height so that this climb point is at our head. And I do 1.01 here. I just multiply that small factor because this is just like a little tolerance threshold to just get the character a little bit farther away from the wall, so they're not directly, so like they're not in the wall. The reason for this is because we're going to do a cool test here. So then we're going to get a target rotation. This target rotation, again, I'm going to use this handy make from XZ, and it's the wall hit normal and the up vector. It's actually, I think, pretty much the same. Is it the same? Well, I have a negative here and I have a negative in this one. But this is just getting that new target rotation that the character should be in. So now I'm gonna give you guys another cool tool here. I use this actually a lot. It's actually really cool. I don't think I've done it yet in any of these tutorials. But basically, I'm going to test if the character can reach a certain target position. And I'm not just going to use overlaps here, because overlaps, I could do a capsule overlap and just test if the capsule can fit in this position. But that tells me yes, if they can fit there, but it doesn't tell me if they can get there, because we want to smoothly bring the character all the way to that point, right? So what I can do that's really cool is I literally just move the character to that position. So I say, here's their current transform. Then I get these hit and return hit results. And I move the character to that target location just immediately. And I set sweep to true. So setting sweep to true means that it'll sweep the character to that position and it'll check if it collides with anything along the way instead of just directly teleporting it. And again, like I said, like this tells me because if I collide with anything while I'm sweeping, that means I couldn't get there. I couldn't transition smoothly to that point. Then I store the result location. So if there's nothing that we collide with, then this result location will be the target location. But if we hit something along the way, this won't work. So then I immediately move the character back. I just move them right back to their current location. And yeah, so effectively they don't move anywhere because this all happens inside of one frame. So the result on the screen is not going to be any change in position. But I do get the important information that they either made it all the way to their to the target location, or they made it to some different location. So then I'm checking here, if the result location isn't equal to the target location, return false. So this is just a cool way to check if you can smoothly move the character to a location without actually moving them to that location, because you move them and you bring them right back. Yeah, I like this a lot because I don't think there's any other like sweep trace function. There might be in the engine. I might not have just discovered it yet, but this basically does the same thing. And oh yeah, so I'm also switching sweep to false on the return. I should have mentioned that because it is more performant to sweep, or less performant to sweep, because you have to account for the sweep, obviously. So you don't need to set sweep to true on the return. And in general, when you're doing safe move update components, you should have sweep to true if you're moving the position. If you're moving rotation, I often set sweep to false if it's a pure turning rotation, like along the z-axis, because you're actually not really changing the physical profile of the capsule. But otherwise, for most physical motions, you want sweep to true so that you don't ever teleport through an object. Okay. Next, we are so after that case is true and we can move to that location. We have a valid climb point and everything's all set. Then we pass all the conditions. So now, if you're familiar with host implementations, basically I have a ton of conditions and I return false out of any of these. And then once I get to this bottom here, that means we've passed all conditions. It's time to go ahead and get us into this new state. So the first thing I'm going to do is set B orient rotation to movement to false. This is a third person specific kind of value. So normally, if you're doing a first person game, you already are going to have the rotation be set to the character's aim, the capsule's rotation set to the character's aim for the roll, for the yaw. But for third person, this just makes it so that the player's capsule will be oriented towards their direction they're moving. That's going to be set to false because in this movement mode, you're always going to be facing against the wall, like perfectly perpendicular to the wall. So we're setting that to false. Then here is where we're doing the transition stuff. So, all of this is transition. So this is very similar to the mantle you're going to see because it's pretty much doing the same thing, right? It's transitioning to a vertical point above you. So we're getting like the up speed, which is velocity dot the up vector, and then we're getting the distance to the transition, and we're getting this queued montage speed, which is going to be a mapped range between these two speeds and these two resultant transition speeds. This is just a little bit of, if this line doesn't make complete sense, this is just a little bit of tweaking to try to make the transition montage speed a little bit more kind of reactive and procedural to the actual speed you're going. So if you transition and you're flying up, like you just jumped a super powerful jump or something, it wouldn't make sense to do a really slow transition animation. It would look like your velocity is randomly just nerfed out of nowhere. So we're trying to adapt that velocity into montage speed, basically. And obviously vice versa. If you're going super slow, you shouldn't transition too fast up. And you can tweak that or get rid of it. It's completely up to you. Then we're resetting the old transition, and we're making a new move to force root motion source, which is, again, like I said, we're using root motion sources here, so go watch the mantle video to see how I do all of that. Setting some parameters like the accumulation mode is set to override. We're setting the duration also equal to the transition distance divided by 500. This 500 sort of affects the speed. You can you can parameterize this, but I didn't here. And then we're also claiming it between 0.1 and 0.25, which is also something you can parameterize, but this is just setting the max and min durations of the transition, because you could be moving super fast, but you shouldn't really do a transition that's faster than 0.1, or it can look kind of glitchy, at least in my opinion, but feel free to change that value. And then, yeah, I logged the duration. You don't need to do that, actually. And then I set the start location equal to our current location, and the target location, obviously, equal to target location. And zero out the velocity. This is important because we're going to be setting the movement mode to flying. And root motion source, if you didn't know, doesn't actually change position. It just changes velocity, and it expects you in your movement mode to use velocity accordingly to allow the root motion source to do its thing. That's why we're setting the movement mode to flying, because in flying you will you'll move just with velocity in any direction, like z, x, y, etc. So basically we have to zero out that velocity first and then set the movement mode to flying so that it will perfectly only use root motion. Then here's where we actually apply the root motion source that we just built up. So the whole kind of pattern here is we're building a root motion source and then we're applying it. And then for animations, all we have to do is we set the transition cube montage to null pointer, because in this case we're not transitioning into another montage. We're just transitioning to this climb point. And then we set the transition name to hang, which again is that new thing I added. So I added a state, a name state, so that I can operate on different types of transitions, because now as we move on, we have more complex movement modes. We get, new transitions into them. And then we're going to play an animation, which is just that transition hang montage. And all this montage does is it goes from the idle state into the hang pose, basically. That's all it does. And then we're using a play rate of 1 over the transition duration so that that montage will play at the right speed. All right, and then I should point out, so that is kind of it, and then I'll jump into the blueprints and show you what other stuff I had to implement to get that to work. But I also do want to point out the last other implementation that I did change was the jumping out of the hang. So if I go to there's a couple other functions I just had to slightly tweak. So if I go to the can attempt jump function here. Before we just had can attempt jump or super or is while running, because we can jump out of a wall run. I added also if you're hanging or climbing, obviously, because you need to be able to press the jump key when you're in these movement modes too to get that overrided function. And again, so I should point this out. A hanging jump is different than the jump button override we did to get into the hang. So we're doing two different things with the jump here. We are overriding the jump key, we're like capturing that and like ripping it away from the character movement component and doing our own logic to enter the jump when we're falling, to grab that item. Then we're also utilizing the jump and letting it pass through the system regular, but then overriding the like actual execution logic of the jump to jump out of a hang. So it's kind of weird, but we're actually changing the jump twice at two different stages in the jump pipeline execution. So it kind of that's something that you could not see at first because it's not totally obvious. But here we're overriding the actual execution of the jump. So we can attempt jump. We can also attempt if we're hanging, or as we'll see in the next system, if we're climbing. And then for the do jump, basically, I have this boolean. So the actual jump override will be the same for hanging and climbing. And basically, I'm just going to set this boolean very similar to while running if we were on the wall. And if we are, then basically we're going to say if we're not replaying moves, because we only want to do this if we are replaying moves, or if we're not. Sorry, if we're not replaying moves. Basically, this is just if you have a desync. Um, oh, actually, that should be outside of there. That's my bad. We only want to play the montage if we're not replaying moves. If we are playing moves, obviously this is important. But so what it is we're going to increment the velocity by the up vector times the wall jump force times 0.5. And then we're going to increment velocity by acceleration.getSafe normal 2D, which gets only a x, y normalized vector of basically the input vector, which is what acceleration is, times the wall jump force times 0.5. So it's just all this does, and you can feel 100% free to tweak this because this is really up to how you want to characterize your wall jumps. But this just allows you to basically get a vertical force up and then also a slightly angled force based on how you're inputting the joystick or the WASD or whatever. So this is, I think, is just cool to give you a little more kind of air control over your jump off the wall. Some other things that I did add. So again, because we have all these functions, if you don't have as fully fleshed out system as we do right now, there's a ton of different functions that we need to modify every time we add a movement mode. So for example, for the get max braking deceleration here, for the hang, I have 0 because there's no braking and hanging. Same with get max speed, I have 0 because you can't move when you're hanging. I believe there's a couple other ones if I just do switch statement on the custom movement mode. So there's max speed, there's braking. Oh, there's the physics, of course. Phys custom. So for hanging, this is, we probably wouldn't have expected this, never seen this before, but we just brake. No physics function. Kind of weird, but that's how it is because there is no logic. I mean, sure, you could add some logic, like maybe you can get the character to lean left and right if they press the input joystick, but I would just do that in animation anyway. I wouldn't even mess with the capsule for a hang. Yeah, there's just no need for a physics function basically, so that's it. Yeah, now let's go to the blueprints and I'll just show you real quick what I did on that side. It should really only just be animation, I believe. Yeah, so if you haven't seen the previous videos, you know that I do all my animations in Engine. I just use this mannequin with a control rig, which I highly recommend everyone check out. I forget what tutorial I did that in, but my tutorial is nothing. I would check out the control rig tutorials so you can see. Just look up animate in Engine control rig, and you'll get tons of tutorials, which these are really cool. So basically, they allow me to make these in-engine animations, and I really only had to make 2. And the important one I want to show you is, let me just go to here, the transition animation. So it is in the hang, where is it? Hang transition, yes. So basically, this transition, the important thing I did here was I go from this idle state, which you see here, and then I go to this state, which is the idle pose for, so if I go to the hang, this is the same pose as in the hang. It's just this like default kind of hanging pose. And so in the transition, the whole key is that I go from rest to this pose, and I do it over 1 second. So here is the 30th frame, and you can see I have 30 FPS. If I switch this to oh whoops, not the curve editor, I can switch this to seconds. You can see this frame is at 1 second, and it's really important that you do it to 1 second because we then set the play rate of this animation to be 1 over the speed, and this will basically mean we can go to this point dynamically based on how fast the transition we set is going to be procedurally based on the distance. So that's just a cool thing that I sometimes use. And then you can see I have this, oh, I don't know why that moves. That's not supposed to move, but I also do another full second of animation that's just the same exact state I don't know why the toes are moving, but this should just be the same state, and that's because you need a little bit of a buffer, because if you don't add this, then technically, because of like frame interpolation, you can go like 1 frame or 2 frames over, but if you don't have this buffer, it'll start replaying the like start pose, and you'll get a snapping and it'll look really off. So that actually took me a while to figure out. But yeah, just add an extra buffer of just the same pose for like an extra second. It doesn't even have to be a second, but I just always do that. Then I convert all these to animations, and yeah, so then I will just say, so obviously this is the hang jump. Yeah. So this is the only other like real animation I made, which is just this little push off that the character does from the wall, nothing special. Then in terms of the actual animation blueprint, again, like, this is not important because these animations aren't that good, and this implementations for the blueprint isn't that good, but I still will just show you guys. Basically, I just have this hang state in my locomotion state, and I literally just play this hang animation because it's just a like idle hanging animation. It doesn't even have any movement to it. And yeah, I don't have anything really else in here besides just that I had to set the is hanging from the I had to set the is hanging variable from the movement component. So really basic. If you're making this for a real game, you should polish this up way more and add cool animations, stuff like that. But yeah, that's it. Oh, and then the other important thing is this just made this very basic blueprint actor that is just this default cube, and I just added a tag, which I believe you can just go to the tags, yeah, and I clicked add, and I made it climb point, and that's all you need to set that up. Then you can go here and go back to the actual level, and you can see I threw a bunch of these in here. You can just add any of them wherever you want. So like here, I can just show me plopping down one of these right here, and then if I play, you can see I run up to one of these, I jump, I press space again, and there I'm grabbing it. You can see me go over and let me grab onto this one. Whoops. Yeah, there you can see I grabbed it. And so now real quickly, I'll talk about, I can't reach from there. I'll talk about extending this system, because this system is, like I said, I'm doing 2 different systems. So I'm going to briefly go over how I would extend this system for different aspects that you might want, because there's too many to cover, but I'm going to cover maybe some different systems that I would think are kind of the most common. So the first thing I think this is probably in Assassin's Creed and other games like that, is that you can climb to points, like this point here, or you can climb to edges where you can kind of strafe across the edge, but you're still kind of in this hanging state. That is actually a lot more complicated, because you're gonna obviously need to store state on like where you are on that edge, and you're gonna need to store data about that edge, because you are gonna have to move. So you're gonna obviously need a phys function, and basically the way I would do that is I would not try to combine these too much into the same system. I would leave hanging to be like its own sort of system, and then maybe edge climbing would be maybe it's a new movement mode, because there really can't be the same movement mode. So you really shouldn't think of them as like the same system, even though visually they look very similar. And then yeah, I would define, obviously you'd have to define another type of actor. You could maybe do a procedural where you can grab onto any edge, but that could be really tough, because then you're dealing with a lot of different edges. So I would probably still stick to defining actors with tags, but then make the actor have a property such as a left edge point and a right edge point, and then you can again do an overlap trace to find the actors in the world that have that tag. But this time you'll check if your character intersects that line, and if they do, you can interpolate, so you can get your position, and then you can interpolate from, say, like the left edge of the to the right edge, and find where your location is along that line, and then that can be your new target hang point, and you'll move to that point, you'll play some hanging animation, and then you can say, for example, only filter out the left and right arrow keys by just dotting the acceleration vector with the character's right vector, and then that can be your sort of linear movement vector, your 1D movement vector, And when you move left and right in the physics function, you'll just slide that target point along the edge, and you'll just obviously clamp that between the edges, and you can move back and forth, and then we can you can leave the jump override and all that stuff to be the same, so you can jump override out of that, and yeah, that stuff will be all the same. So that's how I would do edge climbing. I'm trying to think if there's any other like common ways you might extend this. Maybe you could do another thing where you have like a custom. So if I go and add a climb point that is, say, right at the edge of a wall here. So maybe you might want a like custom mantle animation where you're on this edge and you want to mantle on top of the wall. So that would just involve doing some geometry traces to detect if there is a ledge above you right here, and then just playing, and then you might need to also do a transition similar to the mantle to transition into that state and then play your mantle animation. So yeah, that does it for the hang system. Join the Discord if you want other if you want me to. I'm not gonna implement other extensions to the system, but if you want like an explanation of how I would implement them, I would join the Discord and just like ask me in the CMC channel, and I can just give another overview like this of kind of a top level of how I would modify this system to achieve like another type of mechanic similar or like extended from this system. All right, so next we're going to cover the free climbing system, and yeah, similarly we're going to make a new movement mode, obviously because you're in a completely different state. So that's going to be climbing, and then again, no saved move data because I got that to be nothing, so it's cool. Okay, so for parameters, there's 3 parameters again. There's going to be max climb speed because now you're actually moving in the climbing mode, so we have to have some max speeds here and stuff like that. And a braking deceleration. And this sort of affects like the wall friction you have. So if you want to increase this, you'll see what I mean in a second, but this affects like how much you can slide along the wall, how much your entering velocity has an effect on your climbing velocity. And then there's this climb reach distance, which is just how far you can reach walls in front of you. All right, so now in the C++ here, start from the top. Shouldn't be anything in the saved move data. So obviously I did mention how when we are checking if we can attempt a jump, we're also going to check if we're climbing, because that's going to utilize the same jump as the hanging jump. And that's just when you're climbing, you jump off the wall backward. Oh, and then sorry, I forgot to go over the functions. Just I believe 2 functions here. There is try climb and phys climb. So try climb, very similar to what we've been looking at before. We're just going to check if we have the correct state to climb. And then phys climb is going to actually perform the climb update every frame. And then also there's this climb pressed and climb released. And this is another little tool I'm going to give you guys. So I am using a different key to get into climbing. I just picked the G key, whatever you want. Basically, when you're in the air, you press G, you will, or as long as you're holding G while in the air and there's a wall in front of you, you'll start to enter this climbing movement mode. But I was thinking about it. I was like, okay, should I add another custom flag? I was thinking, what should I do? But then I was thinking about it. I was thinking, okay, like what else do I know that utilizes a flag, but is a state that is completely mutually exclusive from climbing? So when I say that, I just mean you can't enter this state from a climb or vice versa. They're just completely unrelated, basically, and you can't obviously be in them at the same time. And of course, that would be crouching, right? There's no, or that's one of them, obviously. There's just no way to crouch while you're climbing, because when you're climbing, you're falling. So you're in the air, and you can't even crouch in the air. And you have to be in the air to get into and out of a climb. So there's this barrier, there's this layer between climbing and crouching. So that makes them perfect candidates for saved flag reuse. So basically, If climbing is pressed, we're going to check if you're falling, if you're climbing, if you're hanging. And we're going to set wants to crouch to true. So we're utilizing the crouch flag, but we're doing it under the gauze of the climbing mechanic. So it's just like a cool way to reuse, save on bandwidth, save on extra variables and like bookkeeping and stuff like that. And then for climbing release to just false, we don't have conditions here because if you're releasing that key, you always want to set it back to false kind of. So it's just, this is just more secure, more safe. But we only want to ever press that key if we're already in this state of either falling, climbing, or hanging. So, and the reason I also include hanging and climbing is because you can press that G key in a hang or in a climb to just drop out of that state. So you don't have to, if you don't want to be able to drop out, if you only want to exit from jumping, you can leave it, you can get rid of that. But I also want to allow you to exit a climb or a hang from just tapping the G key. Okay, so now let's go to how we even get in here. So let's go to update character state before movement, which is my go-to function for hooking into new movement mechanics. And if we go to, so it's, I believe it's up here, because here's where we're operating on the wants to crouch flag. So first we're going to check if we're in all these other movement modes like walking, sliding and exiting, stuff like that. And then after all that, we're going to check else if we're falling. And if we're falling and we want to crouch, which means we must have pressed that wants to climb, then we're going to try climbing. And if that was successful, we're going to set wants to crouch back to false. So that's going to be where we actually enter that climb. And then else, if we're climbing or if we're hanging and we want to crouch, that's where we're going to set the movement to falling. So this is where we just fall out of either of those states if we just tap that G key. So the important thing is, let's jump into try climb. So this is very small, you can see, because the logic is actually pretty straightforward. It doesn't have to be complicated. And I'll digress here for a second. You want all, like, I remember when I started, I was always thinking like, oh, I want to make really complicated logic that makes cool movement. But really, you want the most simple logic possible. Like if you can do the least line traces, the least vector math and stuff to achieve the result you want, that is always better, because the more maths, the more line traces, the more precision and calculations that you make, the more likely that you'll start to get just floating point and other desyncs between the server. Because if you're just doing a ton of math, say, like there's just going to be a precision drop off and other things that will just slowly allow you to drift away from the server and will just eventually cause a net correction. And especially like if you're doing a ton of geometry testing, because if you're doing too much geometry testing, small differences in character position might result in very different states. Like you can imagine if you only were a little bit higher and you cast a line forward, but you don't see any like obstacle in front of you, and you operate on some boolean that tests if there was an obstacle or not, you're in an entirely new state from just being a slightly different position. So, small number errors can result in large state desyncs, and that's why you try to keep your geometry testing and other math to a minimum. So just wanted to say that first. Anyway, like I said, so this is obviously pretty simple. We're going to check if we're falling, and if we are not falling, then get out of this, because we can't enter a climb if we're not falling. Which just, again, like I said, this just means if we're in the air, basically. So we are going to get a surface hit result and cache that, and then we're going to get the caps location. I just use this as a reference for this value. And then here's where we do the line trace. So we're going to trace with that hit. We're going to go from the capsule location to the capsule location times forward vector, which is just in front of them, by a factor of climb reach distance. And the profile is block, and again, param is ignore all parameters. Pretty straightforward stuff. If there was nothing, so if there's no valid blocking hit, return false. Then we're going to make a new rotation. Also, no surprise, looks pretty much the same thing, but now we're creating a rotation for the new character. So again, they're also going to want to be aligned perpendicular to this wall, or parallel, whichever way you want to look at it, but like just facing into this wall. So that's going to be using the surface hit normal and the character, or the world's up vector, which is also the character's up vector, because this is a boots in the ground game. or not, yeah, not boots in the ground, but always Z-axis oriented game. Um, so then we're going to do safe move component, and we're not going to move at all in the Z like linearly. We're just going to only do rotation translations, and we're just going to use this new rotation. And we're not going to sweep because we're only this should only rotate us like along the z-axis. There's no point in sweeping because we're not actually changing like the profile of the character. And we're passing in that surf hit again. This so this doesn't make sense because now we're like permanently changing the value of surf hit. So I should say this because this might confuse people. We're passing this into the safe move. This is going to give us the hit result if we hit something along the way. I'm only just doing this because I don't want to make another variable, like allocate another variable. I mean, it wouldn't affect performance really anyway, but I just am passing this in because it's kind of just throwing it away basically. Yeah, I hope that makes sense. But if it doesn't, just don't worry. It's just because we're not using this value ever again that I'm just doing that. Then if that's all true, so this was our last condition. So after that, we're green lighted. So then set movement mode to climbing, and we're going to set that again, beat orient rotation to movement to false, and then return true because this was successful. So then I should also mention before I get into the fizz that of course there's a couple different things you need to change every time you create a new movement mode. So if I search back through these switch statements, for get max speed, we need to return the max climb speed. For braking deceleration, we need to return the braking deceleration climbing. And for physics custom, we need to return the phys climbing movement mode. And that's where we hook into our actual logic on a per frame update basis. So we come to here, and hopefully everyone kind of gets the gist of physics functions by now. So this shouldn't be too surprising, but we're doing our boilerplate to check that we have like basically just a correct setup here. And so this time I'm actually not going to do substepping. The reason for that, so yes, that does obviously just make it easier, but that's not the main reason, because it's not that much harder to just add substepping. The reason I'm specifically not doing it is because we don't really need it here. So if you think about it, substepping will get that precision for when you could be colliding with something like mid-frame, and that can change your velocity. Substepping is basically just really good for anytime you could collide with something. So walking, sliding, a lot of these are perfect candidates for substepping. And the reason for that is because it will change your velocity at a smaller increment, and you'll get a more accurate velocity delta for each step in the animation, and a more consistent velocity delta. Now, for climbing, there's not much you can collide with. Like, yeah, you can collide with a wall, but it's not going to, like, reflect or bounce your velocity. It's really just going to stop you, and you're already operating at pretty low speeds because the max climb speed I set was, like, only 300. So we don't need it, and if we don't need it, don't do it, because it can, like, be a little bit more desyncy, and it can, be a little bit less performant. I mean, probably negligible for both those, but yeah, I've never like researched like how much more performant or how much like more network reliable it would be. But at the end of the day, it also is just easier and less to debug and stuff. So I'm just not doing it here. If it was a full release game that I was planning to fully ship, maybe I would still do it. I'm not sure. I mean, I would have to really see if it made a difference, but I'm not substepping in this case. And sorry, if you don't know what substepping is, basically it's just where we break the physics function down into a while loop of smaller delta time substeps and simulate each of those as if it was its own full frame. And then that way, basically we get more resolution of movement in each frame. I believe I did that in the prone video or the slide video. I forget which I went over substepping, but you can find like a really good full explanation in one of those videos. So okay, yeah, basically we just go perform move directly. So we set chest teleport to false. We increment the iterations. That's kind of just boilerplate. We get the old location, and then we make these two hits, surf hit and floor hit, and we cast both of these. So surf hit is going to be the same exact cast we made before, from just the capsule location to the forward vector times climb distance. And we also get the floor hit, which is just from the O location plus down vector times capsule height times 1.2. So this is going to just cast like zero point 0.2 times capsule height farther than the feet of the capsule. Just to check, this is just checking if there's anything like directly under the capsule. So if there's no valid surf hit, so there's no wall in front of us, or there's a valid floor hit, then we're going to break. Because basically once you climb all the way down to the floor, it basically this will just make it so you naturally exit the climb. That way you don't have to like manually press a button if you're already, just look weird that you can climb all the way down to the floor but you're still climbing. So you could remove this floor cast if you want that, but it makes sense for this case. So then if that's the case, then set movement mode to falling and start new physics, because we didn't even simulate the frame, so we're going to let the falling frame. And actually this just shows the cool properties of the character movement component, because when I start new physics here, this will set to falling, right? But falling will actually check a very similar condition, and falling will start new physics into walking. So it's cool that we can do all this in one frame, because it means we don't lose any resolution in our frames for movement. But that really would be what's going on in this little snippet here. And then we return, obviously, because the rest of this logic doesn't make any sense. This is all for climbing. But assuming that's not true, assuming we're still climbing, everything's good. And we have the important thing too is we got this surf hit. Now we're going to go into the actual implementation. So the first thing we're going to do is we're going to transform the acceleration, because when you're climbing, you want to move up and down, obviously. But, you only have WASD or your joystick, whatever. That's usually just X and Y translations. So we're going to actually rotate the acceleration vector by 90 degrees on the, with the right vector of the capsule. That was a kind of a mouthful. But so what this is going to do is basically just shift it so that your forward inputs are now up and down inputs. So W will move the character up, S will move the character down, and then A and D will work the same. Or same, with joystick will be the same thing. Before we do that, we're zeroing out the Z acceleration. But then after that, there will be Z acceleration. This is just that you can't move in or out of the wall, basically. That's what that value will be like when you then rotate the vector afterward. So after that, we're going to apply the acceleration. So we're just using our handy calc velocity function, which I pretty much use in every movement mode. Specifically, also note that we're getting that max braking deceleration, which will return our climb braking deceleration. Then we are setting the velocity equal to a plane projection of the velocity on the surface hit dot normal. That way you can't, again, move toward or away from the wall. This is just extra security, just in case. It shouldn't happen probably, because we already did this line, but I don't know, who knows. I like to be safe with stuff like that. Next, we're actually going to compute the move. So we're going to compute this delta is delta time times velocity, basic kinematic. We're going to check if that's nearly zero, or sorry, we're going to check if it's not nearly zero, because if it is zero, then don't do anything. Don't waste calling one of these on basically no movement. Then we're going to get the hit result, which we always need to make to pass it into these values. Here's where we actually do the move. So we're going to use that delta, and then we're not going to change the rotation at all, and we are sweeping. Then we're going to add this slight wall attraction delta. So this is going to be negative surface hit normal times wall attraction force. This value came from the wall run. So wall attraction force came from the wall, and I'm reusing this logic because it's a similar idea. You want to keep the character up against the wall just in case something were to change. So we're pulling them into the wall, and then we're actually moving them with that wall attraction delta, just so that I actually didn't test. I mean, I know this won't work around corners. That was another thing I didn't do because it was just kind of unnecessarily complicated and specific to different use cases. But I believe this should make it so you can do it around curves. I didn't test that though. But that would be a whole thing you'd have to, if that's a whole requirement for your system if you are going down that route. So I figured I wouldn't specifically talk about that here. Then velocity is equal to, this is just inverse kinematics, just velocity is equal to the change in position over the change in time. Basic stuff here. We've done this in every movement mode, I think. So Before I jump into the code, lastly, I will just show the actual code where I do where I change the transition system. So I believe it was in whoops, update no update character state before movement. I believe here, if I go down to the transition, yes. So all I did basically was I add these just if statements where if the transition is equal to mantle, so now I passed in this, now I actually set the transition name to mantle in that mantle function. So if that's the case, then I just put in basically all the previous logic. This was what was already there, but there was no if case around it because there was just mantle transitions. Now we can also, else if transition is hanging, we're going to do this separate logic where we just set the move mode to hanging and zero out the velocity. So that's just, I just meant to add that. I probably should have talked about that in the hang system, but that's just the way I modified the transition system to be general so that I could use this for any type of system I want. So yeah, I believe that should be everything. I already did talk about how I basically do the same exact thing. So I go to that do jump. I do the same thing as hanging. I literally just check if we're hanging or climbing, and then we do the just same exact logic. It's just a wall jump montage and these forces based on the acceleration. So let's jump into the blueprints and see how this works. Alright, so here we are back in the engine, and so on the actual character itself, just I added this simple G key press just to trigger the climb press and the climb released. Again, I wouldn't do this in like a full release game, but this is just because I'm only covering movement right now. But obviously, set this up in your. I would set this up in my Zippy character class on like the input stuff, and then I believe I do pass in some important the hang transition and whoops, I don't know why that got reset. The wall, I don't know what I call it, hang jump. Hang jump, yes. So those should be passed in there. And then for animations for this, so yeah, again, like don't, I'm just going to show this for completeness, but don't take my animations to heart because they're not that good. But if I go to my mannequin, what I do is I make two different animations. Where is it? I make a vertical climb. So you can see this is just a climb where the character move their hands up and down like this, and then a horizontal climb where they move their hands side to side. And then in my Zippy mannequin animation blueprint, I have a climb state here, and I have a horizontal and vertical velocity, which I'll show real quick. I set these from getting the character and inverse transforming the velocity so that I get this in local space. And then I set the Y value to horizontal velocity and the Z value to vertical velocity. So that Y value is just the horizontal velocity relative to the wall, and the Z value is that vertical velocity. And that's all contingent on the fact that the character has been rotated so that they're perfectly perpendicular to the wall. So that I can just use these simple Y and Z values. Then in my animation graph, when I go to this climb state, I just made a blend space directly in here. I didn't use a blend space like asset. I just made a blend space like directly in the animation blueprint, and I just link in these two values. And then if we hop in here, you can see I just have this going from 300 to negative 300 because those were the values of the max speed for climbing. And then if I hop into one of these states, so if a blend space just blends between animations, yeah, that I'm not gonna obviously cover that because that's like, this isn't about animation, but I was just showing this for completeness. So I just play this vertical animation at the Z value, play rate of 1. At the negative Z value, I show this animation play rate -1. Whoops, -1. So what's cool about that is that it's just the same animation in reverse. That's why I made this blend space like directly in graph, like inline instead of an asset, because as an asset you can only drag on like like you can only place in full animations. You can't edit them. So here I can edit this animation, make it have a -1 play rate, and same for the horizontal. So I have this climb horizontal, and then I have this climb horizontal at -1 play rate, and that's what makes that all work. And yeah, so then just the final result of that is that you can jump, press G, you put your hands on this wall, you can strafe left and right, you can jump off the wall. Oh yeah, there's the animation now. It must have gotten hooked off. But anyway, so you can strafe left and right. You can press W, S to go up and down. And the thing with the blend space is that it kind of blends between them. So you can see, this is not perfect. This is not the best, I should have hand-eye K, I should have other stuff. But you can see when I move on the diagonal, it's kind of naturally smoothing between these different types of animations. So it looks a little bit fluid. I don't know what the legs are doing. Those are kind of tweaking. But yeah, that's just my crude animation system. So yeah, you can jump off the wall. Here's a demonstration of it coming down and it just steps off the wall. So if you just move down and step off the wall, and then also you can just press G again and just fall off the wall. And you can, I believe I didn't show that, but I'll show that for the for these. You can just press G and fall, and you just fall down. So yeah, I mean, for this system, I would recommend for some common extensions. The first one I would say is volumes. Volumes are pretty easy. Basically, just make a volume actor. You can make one in C++, or I think you can also even do it in Blueprints. Probably in C++ though, because you have to reference it from the character movement component. And call this like a climbing volume, and then place this around the map, and then you can basically you can check in that try climb if you're in a climbing volume first, and that will make it so like if you've seen a game where like there's a moss or a rope that you can climb only in that area, or like a net maybe, and you can only climb in that part of the wall, then you place the volume around that moss, and that'll only allow you to climb on that moss. And it won't allow you to climb where the volume isn't. So that's an easy one. For something like a time limit, if you've seen other videos or if you've been in Discord, time is a nuisance. It's really hard to do time-based stuff. You could just have the client keep track of the time and then have the server keep track, but then have the server just what I kind of do usually if I have a time, like a cooldown, is I have the client do the time, not movement save. So they have like just a literal timer or something, and then they send a reliable RPC to the server when that timer's done, and then the server just basically trusts them, but the server will threshold that value within a certain like tolerance. So like if that value is roughly equal to whatever the required duration was, then the server will be okay with that. But the server won't be they won't be actually in sync. It'll still be trusting the client to get that value right. So basically my whole point, so to go with that, is basically you can have the client maybe climb for like 3 seconds, and then the client will send the server, okay, my 3 seconds is up, and exit the climb. But the server will also be doing some thresholding. Like if the server will have another timer running that goes for like say 3.2 seconds, and if the server doesn't get a message from the client within those 3.2 seconds, the server will set the character's movement mode to falling, and that will cause a desync on the character. But that's like if the character maybe was trying to cheat, obviously they should get desynced back to the real version. For stamina, very similar. Except that stamina can be made a completely movement state variable, because if you're not doing time, if stamina was say somehow based on like just distance climbed, so you can just keep track of the delta and just increment the delta position, so just get the magnitude of the delta position in the phys function for climbing and add that onto some safe distance traveled function or something for climbing, and you can set that to 0 when you first try the climb, when you first enter the climb, and then increment that value in the phys function just based on the magnitude of the delta positions for each frame. And then you can just have a threshold in the phys function, like if delta position is greater than max like stamina or whatever, or max stealth position, then just set to falling. So this means the character can only climb up like maybe 3 feet or whatever, and then they lose stamina and they fall off. And then obviously like in game you can get the value of that distance traveled and transform it into a stamina by like mapping it from 0 to 1 and then showing a UI icon and showing like other stuff, and just make that into a gamify it so that the character actually sees it as stamina, but really it's just kind of distance traveled on the wall. I'm trying to think of other things. Yeah, because like really, I think the time aspect of being only able to climb for like a second or something would be cool, because right now it's kind of busted because I can climb up this entire wall. But if you can only climb for like a second or two, you could do like a cool thing where you can like climb up that wall and then jump off the wall, and it allows you to just mantle like slightly higher surfaces, which would be cool if it wasn't for the fact that you could just climb infinitely all the way up the wall. You could also a way you could extend the system is not to is to automatically climb. So you could just automatically, if you detect the wall and there's no mantle to grab onto, you can automatically climb up that wall, and then automatically even jump off that. You could do a lot of automatic things if you want the game to be less input heavy and kind of a lower skill cap. I'm trying to think of any last good extensions. Obviously, okay, so like for edges and stuff, that's one that you might want. If you really want to have your climbing system be really fleshed out and do edges, then you can detect if you're on an edge, because you can trace like to the right and the left of the player and see if there's nothing there. And then once you've detected that edge, you can do traces kind of horizontal onto that new edge to find out the normal of that edge. And then you can calculate the angle of the edge based on the normal of the current face and dotting that with the normal of the new face. And then man, I mean, you could do root motion to get around an edge. If like all your edges are 90 degrees, that would be fine, because you can just root motion and it's like always going to be reliable because it's a 90-degree turn. If it's not, then one thing you could do, which would be cool, which this is probably how I would do it, is I would do root motion with motion warping, maybe to procedurally turn around that edge. Because the thing is, it's not worth making a movement mode to just be handling edge turns for climbing. You know what I'm saying? So root motion with motion warping would be really cool, because then you could pass in a procedural angle that you generate based on turning around like a certain angle, and that will like solve the problem of like turning around angles that aren't just 90 degrees. But I'm not 100% sure how I would fully flesh out that system, because that's kind of complicated to do edge turns. So I would really have to like do a whole like analysis on that. So yeah, that's probably the basic ways I would extend that system. I should obviously show for completeness that all this does work. Whoops, not standalone. Well, I guess that works. Show for completeness that this does work on multiplayer. So, oh no, let's not do that. I should show for completeness that this does work on multiplayer. So, if we go here, here's the server screen. If we go to the client now, we can obviously jump and start climbing, and you can see everything's working smooth. The animations, if I turn on, so if I go to net emulate show packet corrections, and I do emulation packet lag, whoops, not packet jitter, packet lag, set that to like say 250. It's a pretty big lag, as you can see. Okay, there we go. So when I move on the client, I'm delayed on the server by 250 milliseconds. So when I jump up and I grab this point, you can see no desyncs. We're perfect. We're doing better than the walk function. So I can jump here, I can grab, I'm doing all these, and you're not seeing any desyncs whatsoever. If I go into the climbing, everything looks golden. So yeah, this is walking in, or sorry, climbing in multiplayer. If I go to the server screen, just so you can see the animations look good, you can see everything, the animations are replicating because we're only operating on movement mode data. We're not operating on anything else. I can grab this point and push off that. I can jump off that wall, grab onto here. One thing that'd be cool to add, this would be really hard, is like allowing the players to like grab onto each other somehow. That would be really tricky to implement. But yeah, you can see all that's working pretty well. Yeah, so that's climbing. So thanks for making it to the end of this video. I hope you got a lot out of this. I gave a lot of kind of little tools and tips along the way that you can utilize in a whole other types of movement modes. So thanks for sticking it out.